Hello and welcome. This is Camille Fairborn from Michigan State University, and I'd like to welcome you to today's Cause Teaching and Learning webinar. We're pleased to have as our presenters today Grace Zhou, and Dennis Pearl from Penn State University. Grace is a recent graduate of Penn State Statistics Department, and Dennis, who hardly needs an introduction, is currently the Director of Cause and a research professor at Penn State, and also the person who puts together all these webinars for us. For today's webinar, they will give a presentation entitled Shiny Apps Made by Students for Students. The way the webinars work is that all listeners are muted during the webinar. You can ask questions at any time by typing them into the questions box. We'll be sure to ask those questions towards the end and give the presenters a chance to respond. You can also use the chat box if you're having any technical questions. At this point, I'll turn things over to Dr. Pearl. Dennis, go ahead.
Thank you. Good afternoon, everybody. Welcome you to our webinar. We're going to be talking about the Shiny App Summer Program that we have going on here at Penn State. These are Shiny apps that are developed and programmed by students and made to be used in classes by students here at Penn State and elsewhere. So the program, of course, is trying to help both the students participating and, of course, the students that are going to use the apps later on. For the students participating, we want to see that they enhance their skills in R, sort of a fundamental part of our program. We want them to learn the R Shiny R package as a way to demonstrate and investigate statistical principles. We want them to gain experience in the team-based reproducible programming, and they do this by using the GitHub platform in all of their work. Of course, the best way to learn something is to teach it yourself, and so we want the students to enhance their statistical knowledge by working through what it is that are the principal concepts involved in different learning objectives, and to be able to create demonstration of those. And then we want to provide a substantive research experience. And a lot of people have been talking recently about how valuable undergraduate research experiences can be. It allows the student to build up some skills that they can show, to create a product that they can demonstrate, and to help them in any of their efforts, either in terms of admission to grad school if they're going that route, or in developing skills they might use in the private sector if they're going that route. The Shiny App program here also wants to create something good for statistics education. So it's important to us that we build quality web apps for teaching statistical concepts on a modern platform. A lot of the first and second generation apps that were created for statistics education were really terrific, but now have become sort of obsolete in the sense of programs that were done in Java may break, or in Flash. And so by developing them now in the Shiny App platform, we find that they're more widely extended and extensible by others who can take up the code and make them further advanced. The apps in our collection, we've developed a total of 36 apps already. They include both introductory and upper division topics. There's kind of a dearth of upper division topics covered by apps on the web overall, and so we like to be able to contribute to that. And of course, those upper division apps can also be used in applied master's degree courses. So we're hoping to make a good contribution to those as well. And then besides classes in the statistics department, we also want to be able to produce apps that are helpful to teach statistical concepts in other sciences. In fact, this upcoming year in 2019 program, the biology department here at Penn State will be funding one of our students so that we can create Shiny apps that illustrate statistical concepts in biology. The way we organize the program, first, there are prerequisites of being a stat major to participate, with at least a 3-point grade point average, and some skills in R. Our program offers a couple of courses, Stat 184 and 380, they're called here, where students learn R and use it also in their 400 level courses quite extensively. There are 10 students taking part per cohort, and one student who is serving as a mentor from the previous cohort. Those 10 students, one of the things we like about this program is that we're able to handle a fairly large number. We have a pretty large undergraduate major, and it's difficult to provide research opportunities for so many that desire it, but this program is very scalable, and we're able to handle 10 students without having an excessive load on faculty time, because the program is very student-centered and students work in teams and teach each other so much. Part of that teaching themselves and teaching each other involves how they're trained in Shiny itself. So the 2017 cohort took a workshop at USCOTS in 2017, taught by Justin Post and Hurla McGowan from NC State, and the students this year and in the 2009 will take a data camp intro course in Shiny in order to get themselves up and running. The summer program lasts from late May to the end of July. So basically it starts the week after USCOTS and ends just before the joint statistical meeting. So it's all that time between those two events on the statistics calendar. The students work in teams by chapters. As you'll see in a minute, the book has 11 different chapters, and teams work together on an intro chapter, and students work with a different partner in a team on one of the upper division chapters. We have all the 10 students and myself and other advisors. Matt Beckman also helps coordinate this program with me. Have a full group meeting 3 times a week in the morning, usually lasting a couple of hours. These are student facilitated meetings. Students can present their work, throw out challenges for things that they're having difficulty doing, throw out solutions to other students, and we can assign global tasks that where it would be important to have some particular type of code written that could be multi-purpose. So we have those kinds of discussions, and then come back the next day to talk about where we are with things. Students are expected basically to end up producing about 1 intro and 1 upper division app per students. We've had 20 students now in our 2 years of the program, and we have 36 apps produced. So we're pretty well on pace for that kind of level of production. And as well, we can say that that students in 1 year are able to look at the code and look at the features of past years and improve on those, which is one of the useful points about using GitHub. After the summer work, students take a 1-credit group studies course in the fall semester, where we field test the apps in real courses, get feedback on their functionality. We give students an opportunity to present their work at conferences. There's a regional conference here for students at Penn State that present posters on their summer work, and our students participate in that. And we try to improve the apps that semester so that we can do a real controlled efficacy testing in the spring. And we'll be testing 8 different apps this spring in 2019. Our website, the URL is in the abstract for this session. If you want to go to that URL and play around a little bit as we are demonstrating it. And the code for all of the apps is organized on GitHub, and that address is also there. So we'll go to our tour in now just a second. I'll give a brief overview. I want to point out that we would really love to hear your suggestions for different app topics and other comments. And of course, if you find any bugs, we'd like to hear about those. And with that, let me try to switch here to the site itself. So we have here a WordPress blog site, and Grace will be demonstrating things in a minute, is the person primarily responsible for doing this semester, along with her duties in developing apps. So the book is organized in 11 chapters, one section being in the intro statistics, divided up into chapters on data gathering, data description, basic probability, and statistical inference. Our upper division apps we've covered. These are basically for courses, usually here at Penn State at the 400 level on probability, regression, our linear models class, time series, sampling, categorical data, and a data science chapter. If you go to any particular chapter, what you'll find there is the apps that are in that chapter with some brief descriptions of the apps. You'll also find a little ranking of the level of mobile friendliness, where 5 is an app that can be used easily on a mobile phone, and lower numbers indicate that it would not be advisable to use on a mobile device. So here you see a variety of rankings. The apps are also classified according to various tags. For example, here we have a game app. If I click on a tag name, then what I'll see is all of the game apps in the collection. And of course, some apps have multiple tags. Here's an app that is both a game, a multi-level app, uses real data, and is simulation. So from there, of course, I can get to all the ones that use real data and so forth. So those are some of the particular features of the website overall. Again, there are 36 apps total, 21 in the intro group, and 15 in the upper division courses. And now I will turn it over to Grace, who will demonstrate some of the apps that have some of these different features.
Okay, so the very first app is an exploration app. It's under chapter 3, the basic probability. The app is called Law of Large Numbers. This app will give the user the idea of law of large number by themselves based on simulation. And in each app, you can see it. We have an overview page, and you can see the about that will tell you the purpose of this app and the instructions and also the acknowledgements. You hit the explore button, and it will lead you to the main content of this app. In this app, we have a population picker. As you can see in the drop-down menu, we have continuous distribution and also discrete distribution. For example, if I click rescued, you can change your skewness using this slider input, and you can see the population graph will change. If you want to add more paths, you can use this slider input, and you can add multiple paths. And as you can see, looking at many paths shown at the pattern, regardless of the population, with a big sample size, we see that the sample mean converges, and while the sum diverges from expectation. And another thing is the little eye icon here will give you the instructions of the current app. And this home button, the house icon button, will lead you back to the home page. And the next one is a tic-tac-toe game. It's under chapter 4. The app is called Hypothesis Testing Game App. In this app, the user will quiz themselves by playing tic-tac-toe game. So first, you choose your desired square and answer the questions. And then you hit submit answer. Forgive me for 1 sec. Okay, you hit your desired square and you answer the question. You submit your answer. And if you get an O, that means you got it wrong. and then you go to the next question, and if you get an X, that will means you got it correct. You want to win this game by getting 3 X's in a row. And again, if you don't know how to play it, there's instructions down here. If you want to restart a game, you can click this button to start a new game. And the next one is under Chapter 5, the probability chapter. In this app, the matching distributions app is a hand game app. In this app, the students can test their knowledge on choosing the best probability distribution that fits the given scenario. You start this game with nothing on the gallows, and if you provide a correct answer, you read the scenario and then you choose the distribution of the given test. If you don't know what distribution you should choose, here's the hint that you can get for each scenario. Okay, so in this app, you submit your answer, and if you get it correct, you can get number of correct answers increased by 1. You hit next question, and then you choose an answer. If you get it wrong, then you can see a part of the body will be drawn, and if the whole little man is completely drawn, then you have lost this game. The object is to get 10 right before that happens. Okay, and this is the handman game. The next one is under Chapter 7, is the ANCOA app. The ANCOA app will teach students what is ANCOA and how to interpreting the interaction plots. Well, in this app, you have a prerequisite tab, which will give you a little background knowledge to test if you want to explore this ANCOA. So you can check your background knowledge with what method you should use when you know your X and Y variables types. And when you feel confident, you can go to the exploration tab. You can explore with built-in datasets. You can choose different variables and see how it will change in the plot, or you can simulate plots by yourself using these slider inputs and see how the ANOVA table will change as you play around with these slider inputs. We also have a game tab in this app. So you start with a 1-minute time limit, and then you see the time is counting down. The purpose of this app is to match the ANOVA table with the scatter plots. And you play around with this by choosing your answers, and you want to see how many questions you could get correct within this time limit. So in this one, you will choose the answer and then you submit your answer. If you get it all correct, then this icon will be here, and then you go to next set, and then I will just randomly guessing, and you submit again. I got it all wrong. And if you want to know the hint, here is the hint that will give you the idea of how to answer the questions, and this icon will give you the instructions of how to play it. And as you can see, the time is almost up, and now the little jumping window will be here, and then you click OK, you will see the feedback of your results. So I got 50% accuracy within 60 seconds. And the last one is under Chapter 11, the data science app. So in this app, you will see how R code is used for data visualization and reshaping data. The R packages we use in this one is mainly in the overview right here under acknowledgements. So in this one, you can see we have a contour plots, and we also have a heat maps, and you can change color of your heat maps of the one that you really like, and then you can choose different data sets with it. You can explore with your 2-line plots, 3D plots, or using a map. And as you can see, you can always see the R code is plotted here, so you can see what R code is look like to get these plots. And the next tab is the reshaping data. You can see how the data set can be united, gathered, spread, or arranged. You choose your variables, and you can see the transform data set. And again, the R code is always down here. So you can get a great idea of how to code it in real R. And the very last one is the combining data sets game. In this app, so you can select your answer, and you can see the little hint is down here of what is left join, what is right join, and what is inner join. And if you get it, if you check it, and you can see your answer is wrong, and then you check again, you carefully read it, and then you check again, or wrong again, and then you really want to read into it, and you check again, now you get it correct. And by playing around with this, you will get a great idea of what method we are using for data wrangling. And that's pretty much it for today for demo. Thank you.
So these apps are all available at the website. I do want to point out that our server doesn't handle many more than about 60 or 70 simultaneous users. So if you're going to be using these in a large class, you might want to do it as an assignment out of class. And please send me a note if you're going to use them in class, so that we can get some feedback on how things are, so we can improve them during the next summer. So that's it for us, and we're happy to answer any questions at this point.
All right, if you have some questions that you want to ask the presenters, go ahead and type them into the questions box. And I guess I'll start out with my question, specifically to what you said there at the end, Dennis. If we do have a large lecture class and we want to use one of your apps, do we have permission to get the code from GitHub and put it on our own servers? Or would you rather not have that happen?
Absolutely. That's exactly the intention, is that you go ahead and go to GitHub. If you just want to use one app and not necessarily go to our website, that's the best way to go.
Okay.
So for those in the audience that operate a Shiny server, that would be great.
Well, now I just have permission to steal all of this then, right?
As long as you're leaving that Penn State logo on the different ones, sure.
Well, we sure will. All right, we have a question from Eric. He says, how many students are creating each of these apps? For example, for the data science app, is this several groups or one group of students who created it?
We have one girl, her name is Anna, and then she's mainly doing all these things by herself. And we help each other if some question came out. And so pretty much we work in groups.
Okay.
In the overview page of each app, there's acknowledgments that say who programmed. So sometimes there's usually a lead programmer, and then there's often things like special thanks to particular students who helped out.
Okay, I don't know that we have any other questions. Is there anything else that you wanted to present or say to us before we sign off for the day?
On the cause website, I noticed somebody put a comment in asking about participation from other universities. I'd be open to proposals for students from other universities. I'd be open to proposals about how that might work. And so if anybody has that desire and wants to email me with that, we can discuss how that could work.
And assuming that if someone wants to do a similar program, I'm assuming you'd be happy to talk with them about how you set this up.
Absolutely.
Oh, here we have a couple more questions. Suggestions for how to use these in an intro stats or an intro data science course. Do you have any associated course materials with these apps yet, or is that still in development?
That's still in development. I have, for my own labs where I've used these in the sort of the Stat 100 class here at Penn State, I have a couple of different lesson plans for a few of them. As I said, we're field testing now this semester, and we'll have a little bit of that prepared by the end of the semester. And then this upcoming summer, we'll be adding lesson plan content coming down the pike. But that's in development.
Can you then mention a little bit more about how you do the testing for these? When you say you're testing and field testing the apps, what are you doing?
As I said, in the fall, it's mainly just survey data. We want to find out from students. We ask them a question, what did you think of the interface, and did you think it helped with your learning? And we get comments, and usually that kind of helps us know how to improve. And there's also open-ended questions about general comments. And then that helps us improve the apps. In the spring, we're going to do a controlled study. The controlled study is going to work like this. The SAT 100 class has 2 sections, and what's going to happen is over an 8-week period, each section will use an app every other week. And so for week 2, let's say, section 1 is using an app, section 2 is not using an app in the teaching. And then the final response variable is a within subject design. You can see how students did relative to the whole class when they were using apps versus when those same students were not using apps. So that would be the kind of controlled study we're doing, and we're looking forward to seeing some results.
I'm looking forward to seeing that as well. Eric's saying, you mentioned that if we use these apps in class, you'd like an email of feedback on how it went, and is there any other way that we could help?
Yeah, just email dkp13@psu.edu, and we'd love to hear anything about it. I'm happy to discuss with you plans for how to use it and go over the apps and to better describe the intent for the lessons that are supposed to be taught by those apps and so forth. So you've got me as a free consultant if you want to do this, because I would really like to see these used.
All right, and can you put your slide up again that has the sites, the URLs to your site and to your GitHub page?
Yeah, I can. I closed the presentation, so I'll have to open it again.
For those of you who are here live, they are available in the chat.
There we go.
And then just to clarify, someone was saying they missed at the beginning, this software that was used to program the apps was Shiny in R.
Yes.
So, okay. All right. Eric Van says, thank you. This is a fantastic idea. Students creating apps to help teach stats, and a great webinar. And I agree with him. Thank you all for attending. And I encourage you to keep your eyes on the CausWeb webpage and emails coming around for future webinars coming up this semester.
Thank you very much.
Yeah, thanks again. We'll see you all next time.